Welcome back to Mr. RamZland. Today we're continuing our unit on motion, and we're going to use a carbide cannon to find out if a little bit of water in carbide can launch a stopper. And we're also going to find out if carbide can release enough acetylene gas to burn ice cubes. So we're going to start out over here with Amani. Amani, why don't you open up that carbide and put a few crystals into that beaker first? Maybe like, I don't know, 4 or 5. That's great. Put that into the beaker. You're doing fantastic. That's the one. And we know carbide used to be used in miners' lamps as a source of light. And then we're going to pour that ice on top. See how many ice cubes you can get in there. Fantastic. Pour that in there. Keep going. And we know that as that ice melts, it's going to release a little bit of acetylene gas. Maybe enough to burn the ice cubes. Let's find out. What will win out, class? Acetylene gas or the ice cubes? Here we go. Look at those ice cubes burn. Oh my goodness, look at that. So how long do you think these ice cubes will burn? Do you think they'll burn until all the ice is melted? Yeah, pretty weird, huh? Look at that ice burn. Now, is the ice really burning, or is it the acetylene gas that's being released from the carbide? Is it the gas that's burning? Yeah, it's the gas that's burning. And as that happens, this also releases calcium hydroxide, and you can see lime forming at the bottom there. This is a double replacement reaction, and you can see it's still going. Now, another great thing that you can demonstrate with carbide is if you use just 1 or 2 pellets and a little bit of water, that gas pressure can build up and you can launch like small rockets. And so over here, we've got a flask and it's got just a little bit of water. And this time, oh, look which one won out. Is the ice cubes or the gas? I think the ice cubes won out. Let's turn that light back on and take a look inside. Yep, I still see some ice. I see some lime building up at the bottom there. So this is part 2 of our reaction, and I still need your help, Amani. Amani, this time I want you just to put 1 pellet in our flask here, and we're not going to tighten this stopper. We're going to put the stopper on loosely and see if we can pop the stopper off with enough gas. So if you can open that, dear, there you go, and just literally put one crystal in there. That's perfect. And we're going to put this on loosely. And we're going to let that gas build up. And I can see it reacting there in the water. And the gas is going to build up here.
Hit the light.
And we're going to keep waiting until there's enough gas to pop the stopper off. And we know motion results when an object changes location. And so we're going from chemical potential energy to chemical kinetic energy if we can pop that stopper off. You ready? Let's test it. In 3, 2, 1. Oh, there's the stopper. There's the one. Where's that stopper? It went down here. There it is. Down on the floor. So class, that stopper shot pretty high, didn't it? Do you think it touched the ceiling? No, it definitely launched. It definitely launched there, though.
Should we do another one?
So learning how calcium carbide creates acetylene gas that reacts in water, and finding out which one won out here, the ice cubes or the gas. Looks like the ice cubes didn't fully melt, but we saw motion here, didn't we, class? We saw potential chemical energy become potential kinetic energy when that stopper shot off. Pretty cool.